Hello everybody. So today we talk about the system design of LeetCode. So LeetCode is the coding practice platform, obviously, and it's my favorite. Okay, so I will start with the functional requirement. So firstly, user can search the question. User can search the questions, or I should say problems with difficulty. Yeah, and what else? Maybe category or something like that. Yeah, and also user can view the problem on the website, and user can write the code, code the solution in the UI, and then he should be able to submit it, and he should see the feedback of his submission, which is accepted or memory limit exceeded or time limit exceeded or wrong answer. So user So user should be able to, user can implement the code in UI, implement the code and submit. And once he submitted, user can view the result. So this should be accepted or time limit exceeded, memory limit exceeded, wrong answer. And aside from that, also I will, include the contest, LeetCode contest to the feature. So user can submit the sorry. Okay, so user can participate in the contest. And each contest should be, composed of 4 problems in, let's say, 90 minutes. Yeah. And user can see the real-time dashboard of the rank of participants. Yep. Okay, so I will use these as the function requirements. Okay. Okay, so now we'll talk about the non-function requirements. Okay, so firstly, I would go with the cap theorem. So cap theorem is out of the strong consistency, availability, and partition tolerance, the system can support up to 2 of them. And because we are designing the distributed system, partition tolerance is the must. So I have to choose either of strong consistency or availability. So if I choose a consistency, or choose a strong consistency, it means that the system always returns the latest data. But if the latest data is not possible to be returned, system doesn't return anything. So the client cannot fetch the data. But if I take the availability, the system always returns the data, but it is not guaranteed that it is the latest data. Maybe the latest data, the latest update from the process, some process or some client, is not included in the returned result. So that's what happened. That's what happens if I take the availability. And in this question, in this problem, I can rephrase it in like this. Let's say for the second function requirement, user can view the program. Maybe admin user updates the program description. If I take the strong consistency, that the program description is always up to date when user opens the page. But if it isn't possible to return the latest data, system doesn't return the program data. So user cannot view it. But if I take the availability, the system always returns the program data, but maybe it outdated in some cases. Yeah. So maybe the last version is returned. Or maybe for this one, real-time dashboard, I can say something like user, oh yeah, the same thing. Yeah. If user should be able to view the latest rank every moment, or if I take the availability, I compromise it, but the dashboard is always viewable for users. So in this question, I would go with the availability over consistency. In terms of, from the perspective of user experience. So for users, it's totally fine that the program statement is a bit outdated, like 2 or 3 seconds. Or real-time dashboard is outdated for 2 or 3 seconds. Rather, user would like to view it all the time. So I would go with the availability. Okay, next I will talk about low latency. So I have some API endpoint, like user can search programs. So search and view the list of programs. Okay, so search and also view the program, specific program. This should be done within 500 milliseconds. I set this number. And also, we have the real-time dashboard. Oh, no, this one. User can see the result of his submission. Yeah, this API. This is a kind of tricky because it takes more than 500 milliseconds in most cases. Because in LeetCode, user submits the code and the code is executed to test the test cases, maybe 100 test cases or 200 test cases. Even if the backend executes all of them in concurrently, for example, it takes more than 500 milliseconds. So it totally depends on the program and the number of test cases. So I don't set specific number for this, requirement. And for the last requirement, real-time dashboard, this is also kind of tricky because in case of the LeetCode, real-time dashboard doesn't have to be actual real time. So if the dashboard is updated every 5 seconds, it's totally fine. Yeah. So I can say this is kind of near real time. So I would say real-time dashboard refreshed every 5 seconds. Yeah. So now I will talk about another thing. So the LeetCode system, in the LeetCode system, the user submits the code and the code is executed in the backend. And I'd like to guarantee the kind of fairness in the code execution. Because let's say there is a contest, LeetCode contest is going on, and the user wants code is executed so quickly. But the user to the code is kind of waiting in the waiting queue until it is executed, and he has to wait for 5 minutes. It totally doesn't make sense, and it's very unfair. So I include fairness of code execution. And also one more thing, I'd like to guarantee the security too. Because let's say user submits the code which has a malicious operation, and if the malicious code that does something bad in the backend, it's a problem. Maybe it deletes all the data in the database, or maybe it leaks the data to outside of the server. Yeah, it totally something, security risk. So I also guarantee the security of the code execution here. Okay, and now I will talk about the scalability. So the system should be able to scale to, yeah, so this number. So it's scalable to 300,000 daily active users. So the 300,000 active users who at least submit one submission in a day, and 100K users in the contest. So this is the number of participants in the contest. And also one more thing I have to make sure is there is a spike in the contest. So in the end of the contest, there are so many users who submit the code so intensively, I can say. So even if the code is not complete, they submit, and then they get the result and fix it, and then they directly submit the code rather than doing the local check or something. So yeah, the system should support this spike, especially the write spike, I mean, in a system. Okay, so these are non-function requirements. Now I will talk about the core entities. So core entities are like the database name, table names. So I will clarify core entities here so that I can do the API design and high-level design easier. So there is user, and there is program, there is submission, and this actually includes the code and also result. Yeah. And also we have the contest, and what else? So ranking dashboard is a kind of list of users, so I don't include it here for now. Yeah, so this is it. Okay. So next I will do the API design. So firstly, I will list what kind of API. So I mean API names first. So user can search problems. So let's say search problems API. And then we need user can build a problem. So get problem. And also we need user can implement the code and submit. So submission API. Then we need, okay, so there's something I want to discuss here. So if I make this submit API synchronous, the HTTP request is connected and kept alive until the server side returns the result. And as I said, if there are so many test cases, the code execution takes maybe 3 seconds or 5 seconds or more, like 10 seconds. And connecting the HTTP, keeping the HTTP connection for 10 seconds increases the likelihood that there is a connection loss dramatically. And if that happens, the client has to execute the code again and wait for the result to be execution to be done successfully, and the result is returned. So user has to retry. But the likelihood that there is HTTP connection loss is so high. So instead of using the synchronous API, I make it asynchronous. So I use the kind of polling here. So user submits the code and the server side returns the result quickly. So like it accepted the code, and then the client side should make the polling like every 3 seconds. And yeah, now the client fetches the result. So server side, if the code execution is done, it returns the result. And now client, gets the result and render it in the UI. So I'd say fetch result API. This is the short polling API. So I will quickly mention why I can use the short polling here again. So the kind of another idea I can use is WebSocket. Yeah, and the client can immediately get the result if the server side finishes code execution through WebSocket. But I don't use it here because WebSocket uses the different, connection protocol from HTTP. So the infrastructure setup is so, um, it takes so much cost. Yeah. So here, instead of using the WebSocket, I go with the HTTP with short polling because every 5-sec update is totally fine. And with that, the short polling doesn't overload the server. Yeah, actually the biggest weak point of the short polling is the many requests overloads the server, but if every 5 sec, it doesn't occur. Yeah, so I use the short polling here. So now I talk about the user. I did it. So this one, user can see the real-time dashboard of the ranks of the participant. Okay, just to be clear, when user submits the API, the user, or just the client, specifies the contest ID if it in the time window of the contest, and if the user is participating in the contest. So that's how I can, distinguish the submission for the contest or submission for just users practice. Okay. So now I will talk about the user can see the real-time dashboard. Yeah, real-time dashboard. So I think I will talk about this later again, but for now I will, suggest that every 5 seconds, the client makes a request and fetches the ranking of 10,000 users with the score in as a sorted list. So for now, I will go with this, but maybe I will update this later. Okay, so the detail of API. Okay, so search problems API. So this should be get programs and search parameter like difficulty. This is a kind of enum, like hard, easy, medium, and also category. This is also the enum, like binary search, yeah, tree graph or something like that. And for searching problems API, we don't need the authentication. Every non-authenticated user should be able to view the list of programs. So yeah, I don't use the cookie or session token here. Sorry, cookie is needed, but session token is not needed. And it returns 200 with the list of programs. Okay. So get problem API. So this is problem specific. So yeah, it should return the problem And this, again, this doesn't need the authentication. And here, submit API, submit question. So it looks like this. So it creates the submission entity nested in each program. And for each program, user can submit multiple submissions. User can create multiple submissions. So I use the, plural form here. Okay, so in this way, it can create the submission. And for this, I'm pretty sure maybe we need authentication, maybe we don't need it. Oh no, we need it because we have to keep track which user submitted which each submission. So we need the session token here for the authentication. So with this session token, the server side can know which user ID submitted this, code. So yeah, it doesn't need the user ID anywhere. Oh, by the way, of course we need the code here. Yeah. And it returns a 200 status, 200 with, some data about the submission. So I will talk about what are the submission results later when I think of the submission table. But submission result is like status and execution time and memory usage and number of test cases passed. Yeah. Something like that. Okay. So now I talk about fetch submission result. So this is a short polling API. Oh wait, sorry. So no, this should just return submission ID created. Yeah. And with this submission ID, the client fetches a result with API number 4. So get no, I need submission. Yeah, this is it. Submissions ID status. Yeah. And we need the authentication. So with this, it should return the result. Submission result. Like this. So, or I have to say, submission result is something like executing or executed. And in the case of completed status, it should have the status. So this status is the kind of feedback, I should say, result, like TLE, MLE accepted. But this auto status is the status of the code execution. Okay, so the REST API, get real-time dashboard API. So I would say for each contest, there is a ranking. So I changed this to this name. For each contest, there is a ranking. So ranking is now singular. So let's say we don't need the authentication. User who is not the LeetCode, registered user, even for non-registered users, I want the dashboard to be viewable. Okay, and now this returns 200 with ranking, which is the list of users, in a sorted way. And of course, this needs user ID and maybe username and what should I say? Number of solved questions or something like that. And maybe score? No. Or I should say last solved at timestamp. Yeah. So last solved at so what is this? So I mean, let's say there's 2 users who submitted, who could solve the same questions, problem number 1 and 2. So how, in that case, the time which the user, okay, the timestamp, okay, so user 1 finishes problem number 1, number 2 at 9:30, and user 2 finishes problem number 1, 2 in 9:35. In that case, user 1 should win. So yeah, that's why I need the last solved that timestamp. So I can say this is a tiebreaker. Okay, so these are the APIs. Okay, so now we'll talk about the high-level design. So the purpose of this high-level design is, firstly, I make sure that all the functional requirements are met. And I don't think about the non-functional requirements first. And once the high-level design is done, I will talk about how I can satisfy each non-functional requirement. So I have to update my design later to improve the quality. Yeah. Okay, so that being said, I will first, to meet the non-functional requirement, I just have to implement each of the APIs I suggested. Okay, so I will start with the first one, Search Problems API. So there is a user who submits the code, who searches the code. And here I will go with the microservice architecture. The reason why I use the microservice architecture is eventually these systems become so big and scalable. So with the microservice architecture, I can make the domain separation clear. And also, let's say there is a let's say there is some issue in the contest ranking feature. Even with that even if that feature is down, I want the normal feature like code submission to be alive. Yeah, keep working. So by separating those into microservice, I will guarantee the fault tolerance. Okay. So now I will talk about the Search Problems API. So let's say Search Program API is called, and okay, so this is rooted into the program service. So API gateway does the routing, authentication, sometimes rate limiting, and the program service makes a query from the database, like programs data. Sorry. Yeah. So this is the read query. So search. So there is a problem table, and this problem table has the problem ID, description, and what, so maybe test cases. All the test cases are not displayed in the UI, but definitely all the test cases should be stored in this table. And yeah, something like this. Yeah, of course, difficulty and category. Okay. So with this, when user searches the problem, okay, I will use a PostgreSQL here because it's the industry standard. I will firstly choose the industry standard, but if there is specific requirement for database, this database, I will maybe swap this with Dynamo or maybe some other database. But for now, the difficulty search, category search, this is possible with this. So I can say I use the index here, and also I create the composite index here. Yeah, in this way, in these three indexes, when user searches only with the difficulty or only with category or both difficulty and category, I can use the index. So I can find the problems in log n time plus number of questions to be returned. Yeah, maybe we need the pagination here. Yeah, so that's something I can think of, but I don't go into the detail about the pagination. Okay, but something I just noticed is I don't use the index here because for the index of difficulty only, I can use the index for the composite difficulty category tuple. So I don't use the index only for difficulty. Okay, so with this, the PostgreSQL can return the list of problems quickly, and now it is returned to the user, and the UI of the list of problems is rendered. Okay, now I've met the first function requirement. Now the second one, user can view the problem. So this is quite, easy because all it does is just fetch one question. So I use the problem service again. So the request is routed into the problem service, and the problem is returned. I use the ID as the primary key. So in this way, because B3 index is created on the ID column, so it can return the result in log n time. So quick. Okay. So now I talk about the third one. User can implement the code and submit. So I have to think how user can implement the code in the front end. So we need the kind of code editor UI. Yeah. So I can use something like Monaco editor. Yeah. So that's something rendered in the front end, and user can code on that editor. So yeah, and user can submit the code. So I create another microservice here because, as I said, if the submission feature dies, user should be able to view the problems. This is especially important in the LeetCode contest because maybe there is a problem in the submission because of some, very intensive code submission. Even in that case, user should be able to view the problem so that they can solve the problem while he's waiting for the submission result to be returned. So I use submission service. Okay, so here I have to store the data submission. And okay, sorry. I can say I kind of save the submission here. So submission should have user ID, program ID, and submitted code and programming language submitted with, the in which the code is written, and maybe submitted that. And of course, context ID. Yeah, so this is something stored in the database. And of course, I need the result, like which test case is passed and which failed. Yeah. So, okay. So what it does is, firstly, when user submits the code, it writes the data in the submit DB and then returns accepted status to the user. Yeah. So okay. So yeah, that's the first one. User can implement the code and submit. So that now user can do it. But the problem here is who executes this code. So I know that the submission record is created, but who update this result status, test result, and execution time, and memory usage or something like that. So I would use the kind of worker here. So instead of writing the data in directly to the database, this submission service firstly pushes the code into the queue, like code queue, submission queue. So I can use Kafka here. Yeah. So to this Kafka, the submission record is created. Because Kafka persists the data, I can say this is saved safely and persistently. So now when Kafka, accepts the data, submission service can return the accept result. And we need the worker here. So this is the code executor. So this fetches this code submission from Kafka and then executes the code and persist the whole data. Yeah. Okay, so in this way, the code is executed, and now we need the polling API. So for polling API, so let's separate it. So because this submission service can be intensive, and also this submission result showed polling API is intensive, I don't want to mix them, because if I put the two write intensive APIs in the same place, maybe each of them is quite intensive, the other may affect. So I would say submission result service. So short polling should go to this server. So now this does the short polling from submission DB. Okay. So because as long as I set the submission IDs as the partition key, the submission result can be fetched in log time. So again, this is very performant. Okay, so I've now implemented the API number 4, and I have the last one, get real-time ranking API. So when user makes a request to get the real-time ranking, the request is routed into the ranking API. And what it does is, according to the contest ID, it makes a kind of complicated query to the submission DB, and it filters out all the submissions with contest ID. And also it takes a look at only the submissions whose status is accepted. And it groups it by the user ID. And then in each user ID, it counts the number of questions solved, unique number of questions solved, and also it fetches the last solved up timestamp and return it to the user. Sorry, return it to the ranking API. And also again, as well, it has to do the sorting. So it sorts by number of solved question and last solved at tuple. So get ranking query should have the sorting too. And now this ranking API fetches the list of the users sorted with number of questions solved and last solved at timestamp. So now it returns to the user, and in the client side, the real-time dashboard is updated. Yeah, and this API is called every 5 sec from each client. Okay, so this is it. So now I've met all the function requirements. Okay, so yeah, of course, I have so many things to improve. For example, definitely this ranking query is so heavy, so I have to think of the way how I can avoid this. And of course, yeah, fairness and security of the code execution. Probably I have to update this code executor component, and also I have to think of the scalability. But yeah, I will talk about them in the next video. Yep, that being said, I finished my today's system design practice. Thank you so much. Bye.